but it's like the best.
I haven't
It's a private
clarified, like, a
university,
niche
but
of can anyone be on
they
the
have compared to. I think they charge what, 5
Can
clicks?
anyone move on to
Okay, everybody, I think we can start. Alex, I'm just gonna. So the introduce. That's okay. It's not a problem. So I just wanted to introduce our colleague Xuan, who's going to lead this training on the climate change and spatial statistics at the International Statistical Institute's World Statistics Congress. So before we jump into it, I wanted to take this opportunity to share a little background about our speaker. So Xuan works in the Environment Statistics section in UNSD. He works on climate change indicators as part of his day-to-day work. He joined UNSD in 2019, and he previously worked at UNECA, the African Center for Statistics. He holds a PhD in statistics from Oregon State University. So this, without further delay, the floor is yours.
Thank you, Sean. And good afternoon, everyone. It's my pleasure to give this presentation. This is, as some of you might have known, this will be the actually the first session of this year's P2PC training series. So just to give a little bit of a advertisement, like we're planning to host this a training once a week. Is usually on a Wednesday at this time slot. So this will be our first session, and if you guys are interested in the other upcoming session, please feel free to reach out to any of us to inquire about our this year's new training series. So let me just stand up. So the talk today I want to give, I changed the topic at the very last minute. It's now called Climate Change and Spatial Statistics at the International Statistical Institute's World Statistical Congress. Basically, I want to emphasize this is a talk that will discuss about half and half of both the climate change aspect and the spatial statistic area, like especially on how we can utilize remote sensing data on geospatial information to help monitor climate change. So the outline of the talk, there's 4 parts. It's kind of like a match of all different little elements. I want to first give an introduction on the conference that I attended last year. So basically talk about the conference, where it's held and how it went. And then I'll give a little recap of one of my presentation in the conference, access to energy in African settings. So basically this is a policy paper I created when I was still working in the regional commission. That's why it has an African focus, because I was based on the African Regional Commission, the ECA. And the third and the fourth part, I would like to share some of the interesting topics and talks that I've heard from the ISI meeting, and I think some of these you might find interesting and relevant to your work, because it's quite an interesting match between NASA's work, geospatial work, and environment statistics. So to jump into the first part of the meeting, there's a little intro. So basically, International Statistical Institute, or short for ISI, it's the largest organization for official statisticians, and it has 7 child organizations, including the IAOS, the International Association for Official Statistics, the Bernoulli Society, the International Environment Society, and so basically it's a parent organization for all of these 7 child organizations, and they all have their own meeting. The largest one is the ISI, which is once every 2 years, and the second largest is also the what we call the IAOS meeting. So that's also once every 2 years. So those 2 meeting series, they go between each other. So like this year it will be an IOS meeting, I think in Zambia, and next year the ISI will be in The Hague. So last year I had the privilege to attend the ISI meeting, which was in August in Kuala Lumpur, Malaysia. There's about 2,500 delegates from 130 countries, and more than 1,300 papers, so it's a big gathering. And the scientific program lasts for 5 days. On the first day, the Sunday before the meeting, there were short courses on different topics, so they're quite interesting short courses. Unfortunately, I couldn't attend, and there was also a 10K run, which I didn't run because it was too hot. Here are some photos. You can see our very own Ronald was there greeting the Director General of Malaysian NSO, and the meeting is actually opened by Prime Minister Mahathir, so it's a very high-level opening, which shows how important Malaysia have considered this meeting. And the next one, which have already started to gather invited sessions and invited papers, is going to be in July in The Hague. So if anybody's interested next year, yeah, please visit their website. The website is already up. So during the meeting, I did the presentation on the energy access aspect of Africa, which is most relevant and closely related to the SDG target 7.1. So the inception of this paper is because I was working on some energy data in the Regional Commission for Africa and realized that it's lacking development of both the capacity and the data availability of energy access in Africa. So I set out to try to study a little more and try to gather some information and data on how the Africa has fared in terms of SDG 7.1. There were two major the indicator 7.1.1 and 7.1.2. One is related to access to energy, access to electricity, and the other one is related to access to clean cooking fuel. So these are the three areas that the paper looked at. Basically, the total electricity generation capacity and the generation capacity per capita was of my main interest, because we all know that Africa is growing the population at a very fast speed. So although the energy supply increased at a tremendous speed, still sometimes it was outpaced by the population growth. So I want to look at how the per capita impact is on the electricity production. And finally, I looked at the historical progression of the cooking fuel access. So here is a map and a chart. As you can see here, basically this is the overall total electricity generation per capita through the last 35 years, from 1980 to 2015. And the blue areas, the blue countries, are the countries that has grown more than 5 times of their electricity generation. I think some countries like Equatorial Guinea actually grow their electricity production by 30 times. So in the last 30 years, so that's quite an astonishing. It's quite an astonishing feat to witness. Like some of the small countries like Togo, Benin, Equatorial Guinea, Burundi, they all created a fast growth of their electricity. And so are some of the large countries like Sudan, Ethiopia, Mali, Mauritania. But on the other hand, there are some countries, the mark with red, that showed an actual decrease per capita of electric share. So you can see some geographical clustering in this regard, that the Sahel region is doing better and the eastern and southern area is doing not so well in the last 35 years. And on the right side, the bar chart showed the total electricity production growth, and Burundi, for instance, had 8,000% growth. So that's a great achievement. But still, we have to recognize that there's a huge disparity, inequality of the different regions for instance, the southern region have 45% of the entire continent's growth, but Central and East Africa, there's only 3 or 5%. Also, in terms of source, we have still 80% are fossil fuel, so which means that the renewable energy production still have a long way to go. Here there are two maps. One is on 2000, one is on 2016, which illustrate the percentage of population with access to electricity. So as you can see, again, there's some improvement of the number of people who gained access to electricity, especially in the Western Africa region. Northern Africa has already done pretty well, almost 100% already in 2000 and also 2016. But the middle part, there's still much to be done to improve the access for each individual household. So that's on electricity. On cooking fuel, that's a second indicator. I just want to illustrate here that the lack of cooking fuel is both a social and economic problem. It creates fragile healthcare system. It's disproportionately burden women and girls because they are traditionally in Africa are the one who's in charge of cooking most of the time. So in this regard, still much hasn't been done in the last 15 years between 2015 and 2000. Much of the central, west, and east region are still having the majority, almost 80% of the household doesn't have a clean cooking fuel. So this is some areas that really need our focus to work on. Some final thoughts on the talk. Basically, I think this work cannot, this improvement of the energy access cannot be only done by one country, but has to be collaboratively achieved by a region. So there have been some initiative to put regionally planned energy network, like combine some of them, for instance, the Western African countries into ECOWAS regional pool, the East Africans, EAC regional pools. Those have turned out to be very successful and helpful because it kind of balances off the risk and when there's some natural disaster, like for instance, when there's a low flow of river or a fire, then some country might be devastated by their power network, but other country can help out in the regional pool. So those are very important areas to consider. And also that the renewable sources this is a main focus that efforts should be put into, because now still 80% of the time energy is coming from fossil fuels. So and that concludes basically what I presented, which also concluded the boring stuff, and now it's the fun stuff. I think the interesting talk that I have listened to during the meeting. There are two.
Can we ask questions?
Oh yeah, let's pause for a question. Yeah.
Yeah. Where does the data come from? DHS.
There are a few sources. There's from EIA, the energy unit of US, from World Bank, and also from AFREC. Yeah.
I wanted to ask a question about imports and exports of energy between countries. Do you have an idea about how much, say, countries may export energy across borders?
I don't have a precise number on top of my head, but I can tell it's not very much.
Okay.
Most countries still have very domestic grids.
Yeah.
But there are some network or cables are building. Like for instance, I think Egypt, Sudan, Ethiopia are building a network to connect all the Nile power. So it's doing something cool.
Yeah, you said it like the energy generation is good that it increased because of course more people have access to energy at all. But in general, like with with the aspect of the climate change and everything. For example, we probably want less energy generation or less energy usage. And you said that they have 80% in fuel. So do you rather see that they go through the same trend? So they first produce energy with fossil, and then they go to renewable energy, or because you could also imagine that they actually could step over because we already know, okay, this is not good. They have a lot of opportunities for maybe solar energy or something. But you rather see that they do the same what developed countries do?
Not necessarily. This is actually a very good point because there are huge potential for renewable energy, like you mentioned, solar in Africa. This is a huge untapped resource that could be utilized, and there even some. I think World Bank is helping some project to create this off-the-grid solar panel. Basically, they're not connected to any national grid, but they are just give each family a solar panel so they can generate enough energy for their own use, which is, I think, is a great point that you don't have to go through all this pollution and damage and fossil fuel. You can just jump to the cleaner ones.
Yeah, because I guess with communication networks something similar has happened, right? Because the industrialized or the Western countries, they were building fixed line telephone networks, right? And they went straight to mobile telephone networks, or that's how they managed to have such a huge growth in usage of telephones. With respect actually to this question about those household units production of energy, is there any data on that? Or I mean, it's easy to get the data on big power plants, I guess, but how does it work for those small units? How do you get actually the data on how much energy is produced there?
You mean the data on the off-the-grid?
Yeah, exactly. So the small ones, solar panels or whatever.
I don't really know. I guess you can estimate by knowing how many panels is out there multiplied by. But you're right. There's no way to really.
So a follow-up on my previous question. For measuring these SDG indicators, do they use or do they consider using the satellite images with the light and then the population density information to measure SDG 711? I think like that could be an innovative,
maybe
an alternative source. Yeah.
Maybe somebody from the SDG section can answer this.
Is it cheaper to get energy from fuels than from solar, for example? Is it cheaper to build a factory?
Yeah, because you have a one-time cost of purchasing those panels, and this could be quite prohibitive for the rural areas.
But then, of course, in terms of access to energy at all, for the whole country, it's then often much easier because you don't need an electricity network, right? So you can just put the panel there, and it's just for the local area or for the single household.
Build those big towers and lines. Okay. Thanks. All right. Let's move on to the next one, third part. So this is I want to explore this this paper, which is based on Professor Noel Creasy from University of Marcos Claremie, University of Wollongong. Wollongong, yeah. So he used to be a big figure in the spatial statistics area, and so it's nice to hear him talk about some of the research he has done. The first one is about measuring atmospheric carbon concentration. So we all know that greenhouse gas is a big problem, and the carbon dioxide, it's increase in concentration in the Earth's atmosphere. So as that chart on the right perfectly illustrates, it's going up. So the point here is the Earth's total carbon stock is constant, but too much of it released into the atmosphere, and there's no way for them to go back to the water or the soil. So the problem is that although the greenhouse gases only make up to a tiny percentage of Earth's atmosphere, it plays a very significant role to capture and absorb the sun's radiant energy, and therefore the heat will heat up the Earth, and now we have global warming. So as you can see, if this is the composition of the Earth's atmosphere, then most of them are nitrates and oxygen, and only a little bit, and argon here, only the 0.04% is greenhouse gases, and the majority of it is CO2. Actually, there's another element that the water vapor contributes to more of the greenhouse gases. It's actually the largest by volume, but at least it can come down as rain. The water vapor come down as rain, whereas CO2 are not coming out of the cycle of the air. That's why most scientists are more concerned about CO2. So this is a toy example of how the Earth's carbon cycles go around. So you can see there's a lot of different elements that. So these are taking stock of the carbons and exchange them between different ecosystems of the planet. And these red arrows are the ones that we're interested in to keep track of, or we were hoping to be able to manage. So like burning trees or power factories generating power by emission, and cars and cows, and all of these are the human elements of the carbon exchange. So these are the elements that we can control, which contribute to the carbon concentration in the world. So, and we all know that there was a saying that if you cannot measure it, you cannot manage it. So there's a big problem of how do we measure the carbon so we can manage our emissions. So this is what this NASA satellites come into play. So NASA have, throughout the last 10 years, launched 3 satellite or unit into the space. They're called Orbiting Carbon Observatory, or OCO. Basically, the first one was launched in 2009 and it failed. It didn't reach orbit, so the whole thing just drifted away. And usually, when in the rocket science, I think if something failed, that's it. You spend millions of dollars, it failed, and you don't have a second chance. But because this is so important, the Congress actually approved budget and funding for a second chance. OCO2 was launched successfully after 5 years. So most of the data in this presentation is coming from OCO2. And then just slightly less than a year ago, last year, they launched the third one, which is a much more precise observer but this one is not a satellite. It was launched as an element of the International Space Station. So what it does, this is an artist illustration of the OCO2. It has a microwave passive sensor that just basically scan as the satellite flies through Earth. It scans the atmosphere, and based on the feedback of the microwave, decide how much concentration of each element is in the Earth. So it's pretty cool. So that begs the question. Sounds like fancy science, but what does statistician can do in this kind of work? I think we can argue that we're not completely useless in NASA's eyes. That in terms of statistics, we can help to, as a statistician, we can help to improve the precision because we know about all this probability series on how to predict and estimate the error terms, right? We can improve the precisions. We can estimate the base levels because every measurement or even the satellite had to calibrate to the base level. We can help with the base levels. And we're good with imputation, so when there's missing data and gap filling, that's where statistics can come into play. And also to convey and to steer policy decisions, we should be able to pass those knowledge, and especially the uncertainty of this knowledge to the policymaker, because not only are the estimates or the readings important, the error term and the standard error is also important. So that's some areas that statistician can help in the earth science. So here, this is a picture or a map of a 1 day of these OCO2 satellite as readings. Basically, it rotates Earth, I think, a couple of times per day, and it records on its path the concentration of the carbon. So this is just 1 day in New Year, January 1st, 2017. You can record this much data. And on the second day, it will record on a slightly different path. So all of this add up together. In about 16 days, you can already see there's a pretty good picture of what the Earth's concentration of carbon look like. So the red areas are the area with a higher concentration, and the bluer you get is lower concentration. And some of the area you can see have no readings, I think because of some atmospheric, like basically weather system that stopped in the Amazons, in the rainforest around Africa here. So it doesn't always capture the carbon reading, but yeah, the weather has to be in a agreeable position. So this is 16 days, and this is a 16-day reading in July. So the obviously season varies between the boreal summer and the boreal winter of the north. The concentration of carbon will decrease or increase accordingly because more vegetation will grow in the summertime, which means that less carbon. And in the end, I don't want to go into the modeling, the spatial modeling details, but in the end, we can come up with maps such as like based on the data we have and the statistical inference. So these are the two maps that we see, and this one is basically from the reading of the satellite. We can come up with the estimate of the global picture. It's called kriging, basically in spatial term. Kriging means, it's a fancy word for estimation. So basically a spatial estimation is called kriging. So taking into account of all the areas where it's no data. So we can still have a good picture of where the concentration of carbon is. And in the end, here you have the standard errors of the kriging of the estimate, showing which area is more the scientists have more confidence in their estimate. This is a video. I'm see can play this. It's a pretty cool video showing the final generated estimate of the carbon. So all of this is coming from that data sets. Lastly, there's another paper I want to share with you guys. It's the spatial change of Arctic sea ice.
Can I pause? Can I say, do we have any questions maybe on the last part, just because it's fun to answer?
Yeah.
Any questions on this? Really cool. I have a question. Just looking at this simulation of the, I don't know anything about this, but I wonder how important is reforestation in controlling, when you talk about the role of, you said the trees come back, which influences somehow the amount of carbon. Is this something that is measurable in a certain way, that the contribution of how much reforestation it would help reduce the role of carbon or the impact of? Do you kind of understand what I'm saying?
You mean like do it in a targeted way, saying, oh,
well,
here.
I was just wondering how, I guess it's multiple levels, like how important is, so it also goes back to that slide where you had the different carbon contributions from volcanoes and all these things. Just as an order of magnitude, is the carbon problem something that we could solve by engineering natural solutions? So humans are causing climate change. Are there ways we can use natural systems, improve the health of our oceans, or these natural things that reduce carbon in the environment? Is this such a high order of magnitude difference in the problem that these would be totally a drop in the bucket? I guess is my amateur question.
I guess no effort is too small. Well, you can observe from this video, right? It really made a difference when the season changes. And when it comes to July, the level of carbon really dropped quite. So a lot of the red area became green and blue. So of course that's contributed by all the vegetation. But I think, doing reforestation is definitely gonna help.
Perhaps as a comment, so for instance, as part of the CIA, we're developing also carbon accounts. So basically, they try to capture in a comprehensive way all the stocks, carbon pools that you can distinguish, by ecosystem types, and of course also all the fluxes that were, I think, in one of your, Le Claret, this sort of carbon cycle picture.
Yeah. Could we look at that one? Steiner saw this. They had a nice graph.
Yeah.
This one.
And some countries have done, so like in Australia and also the Netherlands, they have compiled these quite comprehensive sort of carbon accounts. And that's quite nice because then you can compare, because you have, the IPCC framework and there's LULUCF that captures, some of the things you're discussing. But of course, they have a perspective of only capturing the sort of the anthropogenic changes. So certain emissions, for instance, for, peatlands where there's, let's say, drainage, it's considered in the IPCC framework as sort of natural emissions. So they happen. And you would pick them up here with the measurements that you described, but they would not be accounted for in emission inventory. So having sort of a carbon account or sort of these frameworks, allow you to sort of have an overall picture of what is happening. And then of course, what we are working on is measuring different types of ecosystem services. So there's carbon sequestration, carbon storage, etc. So you try to sort of capture also these changes. But what I think is very interesting here is basically because a lot of it, of course, is based on estimates and sort of you have emission factors based on vegetation types. But of course here you measure things from space. So I think it's sort of a another data source you can contrast and compare with to sort of see whether things that, let's say, countries report sort of match up with what is actually measured from sort of the atmosphere.
I'm curious, in the CIA account, is there like a total global account or is it only by countries? Can you just simply add it up and say this is a global carbon account?
I think if all countries would have these comprehensive estimates, then we would be able to add it up. But I think there are many, before we get there, I think it will take a long time. But and I think also, all the interactions with, for instance, oceans and how that, I think that these are, quite uncertain, I think, also in this global carbon cycle, what these amounts are. But there's a lot of, I think, also remote sensing products, like here, look at, NDVI, it is a good estimate of carbon sequestration. So that sort of answers that question where it's really where sequestration is taking place.
Sean?
Yes.
I didn't get a chance because this is an article that just came out today in the Times. There's an op-ed today that's actually like and there's a lot in the article, and I only quickly read through it, but basically it's on the very topic of how much can trees do to like counter
climate
this,
change.
and I think it had to do with like the trillion tree planting project and how he's like, yes, it helps and it's a good step, but there are limitations to that, and again, there's a lot in the article that the authors, who are all like climate scientists, reference that need to probably be drilled down. But
Very cool. Thanks.
Do you have any information on the status of UN-led carbon exchange program? So a few years ago, like UN initiated like kind of like carbon credit. Like,
carbon trading scheme.
Yeah, carbon trading. Yeah, any status on that?
That's not something I'm very familiar with. Carbon trading.
That's been trialled like within Australia between businesses. So this business can buy carbon credits from the government and then emit carbon or trade them and so on. It's been quite unsuccessful in my country.
Yeah, that's what I have.
Also within Europe, it was not as successful as they wanted it to be. And here in the US, it doesn't happen. So if one of the biggest polluters in the world doesn't do it.
I apologize on behalf of the people.
I know that you said about the data source is from NASA. But then, so is it like, is this trustworthy? Is it a trustworthy data source? Is it the only data source, and is it trustworthy?
Well,
Independent.
I would love to unpack that question somehow. Maybe we can just answer it and we'll unpack it later.
It's going to be a 2-hour discussion.
So, but it's the only data source that they can use.
I didn't research the whole thing. I'm sure there's other agencies that will probably publish other data sources, but
just to note, this is sensor data.
Yeah.
I mean, it's information that's coming from a sensor that's been calibrated and.
Yeah, but they don't change it, for example, if they want to change it because they want to discuss that it's not actually a big problem, maybe.
Oh,
because of,
you mean
so is there political influence in what they do? Or
They
not?
just cut the funding, and then
there's a principal agent. So the evolution is that there's a principal agent relationship between the policy and the technical body at NASA. So you could, in theory, but it's a very hard thing to push inside the bureaucracy. So I mean, that's just my expectation. But
So it's more likely that it's the actual data.
that's my presupposition, but I have no first-hand knowledge.
Yeah.
Okay.
Okay.
One more.
Right.
That's all right. Yeah, just on the seasonality within year and in the video that you shared, I just want to make the observation that surely well over half of the Earth's population reside in the northern hemisphere, and there's much less people. But I don't know the world's forest cover or tree cover is in which hemisphere, because that's not population contingent. So yeah, I just wondered how much the southern hemisphere would be counteracting some of the seasonality. Certainly not in terms of demand for energy and emissions of carbon, but in terms of tree growth.
Well, if you look at this video, like to show it again, I think most of the southern hemisphere is water, right? It's much more water than land, so it doesn't really, yeah.
So they're not so big.
Yeah.
Yeah.
So they always have a very strong bloom stream, which means,
Right. Okay.
yeah, like.
But I wonder if it's
Plus it's easy.
Yeah.
In winter.
Yeah.
Even in the southern summer, you don't see that much carbon
Okay.
around the northern part. Yeah. Okay.
I'll have to watch that later and see the whole thing, you know.
Yeah. Okay, so the last bits we looked up to the air. Let's look at to the ocean. So this is about the retreat and expansion of Arctic sea ice. This is also a satellite sensing topic. One of the other topic from the ISI meeting, this I found very interesting. So we know that the sea ice have this reflecting feedback, right? So basically, the more ice it is, the more sunlight is going to be reflected back into the space. And if there's less ice, the darker water will absorb more heat, which in turn melt more ice. So this is a feedback loop. And in the last 35 years, they have been recorded that for both Arctic and Antarctica ice shelves, there's be a decrease in terms of the size, the cover of the ice shelves. So this is an annual chart. You can see there's some year by year there are some big jumps, but overall trend is a downturn. And with respect to particularly the North Pole, in 1979 compared to 2013, you can see the retreat is quite obvious. So the blue areas are the purple areas are the area with longer days of sea ice, and the color spectrum shows that much more areas are now prone to a very short ice time and very small, longer ice time areas. The middle part, the black circle, there's no data because we believe there's always ice. That's just for convenience purposes. So to understand and to model this type of ice cover, it's easy to make these response or the ice response variable as binary. So basically, you can say we can measure in this 1 square kilometer area how much ice is there, but for convenience and for ease of modeling, usually it's taken as a binary response, which means that red ice, blue no ice. And the cutoff of that is whether in that particular cell of sensing that there's more than 15% of ice. So if there's more than 15%, we just treat it as ice. Less than 15%, there's no ice. So in this paper or this research, we now have two elements. We want to know both the area of the ice, which is a time element, and also we want to know the year-by-year change. So that's a time element. So that's why this model is called spatial temporal model. Is consider both the temporal effect and the spatial effect with binary variable because they're 0-1 variables. Again, the source this is a NOAA and NSIDC collaborate data set. It's called National Snow and Ice Data Center. I didn't know this exists until I read about it. So the precision is down to 25 times 25 kilometer lattice, and they have a satellite that looks something like this one that record every day the ice cover of the Arctic Circle. So basically, the data collection is continuous, and for modeling purposes, we use the September data only because that's usually the month of the year which has the least amount of ice. And the data were confined to the latitude which is greater than 60 degrees north. And as you can see, in the middle, the North Pole, there's no data collected because the response is always 1. The question that, again, that statistician can help to answer for these Earth scientists are, we want to predict future sea ice cover given the current trend and the current meteorological, physical, chemical, and ecological development. So here I want to give a very quick introduction of the spatial temporal model and how this type of thing come about. Basically, we know that the response is ice, no ice, so the binary response over time and space, so that's the spatial temporal name of the model. We also call the binary response Bernoulli response, 0 and 1. And in this case, we say that, so basically the data are each of the dots of those blue and red areas. They're conditionally independent. Most of the, if you remember your stat course in graduate school, most of the time the easiest modeling, you assume that data are independent to each other. But here, because it's the data recorded on a spatial pattern, they cannot be considered independent because we believe that things that are closer to each other are more similar to each other. So that's why we call it conditional independence, which means that the two responses are conditioned on space independent to each other. So that brings us into this the definition of conditional independence. Basically, if two random variables are independent to each other, only given a third variable, that's what we call conditional independence. A good example is if you consider a child's height and how many words he or she knows. These two variables are not independent, but they're conditionally independent if you know the child's age, because the age determines both the height and how many words they would know. So in the conditional independence world, the most prevalent inference tool, the model is called the Bayesian statistic, which is all coming from that equation on the right. Basically, it means that to summarize, it says that the posterior distribution, or what you have guessed from your model, is coming from not only the data, but also your prior distribution. So you have some prior knowledge or confidence in the model, and then you add on to the data, you get your estimate. In our case, we take the modeling part and the space and temporal observation of the sea ice as the prior of the Bayesian model. This is the only equation I'm going to show, but there's no more. So just bear with me. I just want to explain a little bit more. Basically, a spatial temporal model means that this is the response. This is Z is the ice or no ice. It's conditioned on Y, which is the space. And the space is dependent upon T, which is time, and S, which is S. So, which means that if you know the location and the time of what it happened, then you can treat the ice or no ice response as independent, which is following a Bernoulli distribution. And that's the basic of the spatial temporal model. And with regard to that, we can also specify the space part as a mixed effect model, which means that it has some independent explanatory variable plus some dependent random effect variables. So those two parts will link the time and the space together. So this is basically what it means of the conditional independence of the spatial model. Okay, that's it. So this is the result. The result showed that with this modeling that we are talking about, you can successfully predict the upcoming year's sea ice melting. So basically, the red areas are the areas that have a probability of changing from ice to water. So you can see that how the ice has retreated from the lower latitude. Yeah. Yep. with regard to that, the last part I want to talk about is how would these work, the two papers that I just presented, is relevant to our section's own work. So in our section, we have been mandated by the Statistical Commission to create a global set of climate change indicators. And we have already done some significant work in the past few years, and by looking from a bottom-up approach to look at about 132, we have already looked at 132 countries, national plans, strategic plans, and action plans, climate change, environment statistic, and such and such. And we gathered about 75,000 data points from those 132 countries and categorize them and summarize them into a list of indicators. Now we have about 130 indicators. We're still improving on that list. So we did one round of expert consultation in this Christmas season, and the next round is coming up in this month or so, and we're also planning to do a global consultation this year with the expectation that this will be presented to 2021 Stats Commission. So this is the relevance of these CIs and atmospheric science to our work. That in our global set of indicator, we already included on the right reduction of sea ice cover, atmospheric concentration of greenhouse gases, total greenhouse gases emissions, such and such. So this will be included in our indicator list, and I think to note that how in the global setting these remote sensing data are collected is going to be very helpful for our own work in creating this global list of indicator. So that's pretty much all the talk. I have some very final thoughts that we hope that with the effort of climate change work and spatial statistics, the Earth's global atmosphere will become a more stable environment, that snow will fall and ice will form in the Arctic every year, and majestic animals such as giraffes can roam around worry-free in the planet. And even more so, I have a dream that one day giraffe can ski one day. Nothing is impossible. I have a video to show that. You snow and then
Hey, Georgina.
her name is Georgina. Yes. All right. That's it. Thank you.
Man, thank you very much. That was an amazing presentation, if I can say so. Just going to stop the recording.
All right.
Well, are there any final questions? Any comments or inspirations you had that you want to share? I have one. I was going to wait. I just was curious about the last two methodologies you presented. So looking just at the Bayesian estimation of the one period in advance what ice is going to melt. Is there international? Are there statistics that are produced on the basis of this methodology or projections? Because this paper was from when it was 2014. I don't know. So are there data that are regularly generated from this, or is this something that is still in the realm of scientific prototyping and research? Are there agencies that are sort of using this in production, or is this?
Because you see now you have the satellite, you have the component on the International Space Station. They're basically collecting this data nonstop on a real-time basis, and this data it's all open source. Like anybody can go download it. Every day they will put new data from yesterday. So basically it's a real-time tracking of where the
Sure. I was thinking about the ice.
The extent of sea
melting.
Yeah.
I was just thinking, are there other regular projections that are produced using this method, or is it, just looking at, what the sea ice melt is going to be next year?
I believe so. Yeah.
Okay.
It's doable, definitely.
I just have one thought. So if the ice melts, it's not all bad, right? It also has environmental friendly consequences because the distances to travel to transport certain goods is decreased because now you can use the northern passage, right? And you can basically take a shortcut, which will also mean that you will have less fossil fuel consumption to transport certain goods from one point to another. So also can have some positive effects.
Never thought about that way. Yeah. This is a silver lining of the ice melting.
So there's also a positive feedback,
Yeah.
or some maybe minor ones, but
Tell that to the Maldives as they go. Floop, floop, floop.
Canada will be happy about that.
Canada for sure, yeah, and even the US. I mean, for certain goods.
My hometown will become a hotter, happier place.
Yeah, maybe you.
So these global set of indicators that you're coming up with, have you done a data availability analysis? Like, would you happen to have data for many of these indicators, or
It depends. Some of
are there
them.
many data gaps?
Some of them, like the popular one, like greenhouse gases, there are a lot of data. Almost all the countries report or have strategy to collect them, but some of them are scarce. Like we have some indicators such as, for instance, urban green space, like how much green space is in the urban areas. Those are not very well documented, so it really depends. Yeah.
Probably it's quite depressing to look at data that shows how much the ice is melting and to work in this field, but like do you really do we only is our only concern like good statistics and good data, or is your job also to show here this is what we found and to disseminate it like really with pressure, or is it just focusing on the data production?
You mean in UNSD?
Yeah.
We should do a better job at not only producing our own data, but to announce all the other data, I think. Right now, we're not doing much of that.
But is it technically also what we should do, or is it just not our task?
Well, this type of data is not official statistics or scientific data, right? So it's not really fall into the fundamental principle for official statistics, but nevertheless, I think it's really helpful to know this existence. And
because if it is as long as it's the research, probably a lot of politicians don't listen. But as soon as this comes from a big organization, maybe it has more impact.
Yeah, but as soon as we start putting forth an opinion, we sacrifice our independence as official statisticians. I think we shouldn't do that at all.
But it can become official statistics.
But some people won't listen, regardless of the source, right? So
I think we're just talking about producing data based on some of these methodologies, you mean, right? And bringing this into, or do you mean pushing out more of an interpretation or in policy advocacy?
No, but I just wonder if you can measure this, and if there are ways to measure it, like if we step from we can actually produce this, we should also announce, like, yeah, this is what's going to happen.
Like if we have a forecast that says something to make a big deal about it, something like this.
Yeah, or just like make your voice heard. Because as long as it's like, I mean, nobody is going to read the paperback crescent.
I know, and this is
no, because like I mean.
This has always been a debate in official statistics, as far as I can tell. You have certain NSOs like INSEE that are much more aggressive about pushing policy interpretation and really, and I think in the West, in the Anglo-Saxon tradition, and maybe Germany, there's much more of a focus on absolute independence and data production and just the facts. And this is important, I think. And so I have my own opinions on this, but I always think there's room to make the message clear. I think you can still do this without crossing into normative conversations.
I mean, you're totally right. Like it's like it should never sacrifice any of the principles in that sense, but it could also push it forward to have official, like, to make it official statistics, and then you can actually use it.
I think your relations with key stakeholder institutions are paramount as well in a national setting, the federal government, line ministries. I mean,
one of the things that I know, at least some statistical offices that have compiled, I mean, there are different sort of organizing frameworks, right? So there's the IPCC that's looking really at sort of human-induced, let's say, emissions. But then you have also the actual measures that are taking place, and and then there's accounts that look sort of the connection with economic activities. And in some countries, like for instance in Denmark, but also in the Netherlands, you sort of see that compared to the IPCC, emissions go down, right, from 1990, because but the actual emissions, for instance, they show stark increases. So and sort of that gap is, I think, something that statistical offices have had quite some success also communicating, making national headlines and so on. Yeah. But I think that's all sort of within the national domain, and I think some of the things here were more like global kind of statistics, right, on the Arctic ice or gas concentrations, and there I'm not sure who would. Yeah, I could imagine
the UN,
the global nature that it would be
maybe it's our responsibility.
More within our mandate.
But also, like, I mean, the Netherlands and Denmark, they're probably good because they also care. So I just think, like, with this topic, it's difficult because of a lot of countries don't want to show emissions, or they don't want to have these numbers, and it's just a question of, like, if this is a special topic where an international organization should step up. Because it's not national, it's not a national problem.
Well, I'm going to stop recording.
You stopped the